Most glaciers on Earth are doing exactly what you'd expect in a warming world, shrinking slowly year after year. But scientists have now identified more than 3D100 glaciers that behave in almost the opposite way. They sit still for years, sometimes decades, and then, with very little warning, they explode into motion, surging forward fast enough to overrun roads, dam entire rivers, and create lakes that can burst without notice. One of these glaciers has already destroyed a major highway bridge more than once in Pakistan. Researchers have identified 81 of these glaciers as posing the greatest danger to the people living beneath them. Today, we're breaking down what a surging glacier actually is, why climate change is making these events harder to predict, and which regions on Earth face the greatest risk. No guessing, no dramatizing, just the facts, the science, and the real stakes. What a glacier surge actually is. According to a major global study published in Nature Reviews Earth and Environment, led by researchers at the University of Portsmouth, a glacier surge happens when ice that normally creeps forward at a slow, steady pace suddenly speeds up dramatically. During a surge, large volumes of ice rapidly transport toward the glacier's front, often causing significant visible advance in a way that can genuinely be observed from one day to the next, a stark contrast to the barely perceptible movement most glaciers exhibit under normal conditions. According to Durham University, one of the institutions involved in the broader research effort, these surges are driven by meltwater accumulating beneath the glacier, which reduces the friction between the ice and the ground underneath it, allowing the glacier to slide forward far faster than it otherwise could. According to phys.org's coverage of the related research, surging glaciers make up roughly 1% of glaciers worldwide, but account for about 16% of total global glacier area, meaning this relatively small group of unusual glaciers represents a disproportionately large share of the planet's total ice. These surge events typically last for several years once they begin, and the same glacier often experiences repeated surges separated by decades of relative inactivity in between, according to phys.org's reporting on the study. The global database scientists just compiled this international research team, led by Dr. Harold Lovell and colleagues, compiled what the University of Portsmouth describes as the most comprehensive global database of surging glaciers ever assembled, documenting more than 3,100 glaciers with confirmed surge behavior. According to the university's own announcement, these glaciers cluster in dense concentrations across specific regions of the planet: the Arctic, the Karakoram Mountains in high mountain Asia, and the Andes Mountains in South America. Within that broader database, the research team identified 81 specific glaciers that pose the greatest danger when they surge, according to phys.org, with the majority located in the Karakoram Mountains, a range spanning parts of Pakistan, China, and India, where populated valleys and critical infrastructure sit directly beneath these hazardous ice formations. Dr. Lovell explained the practical value of this mapping work directly. Understanding which regions have concentrations of surging glaciers helps researchers plan monitoring efforts and understand future behavior, while knowing which specific glaciers pose the greatest risks can help protect the communities most exposed to them. It's worth walking through exactly what makes a surging glacier dangerous, because the risks extend well beyond the ice simply moving faster. According to the research team's published findings, cited by phys.org, a surging glacier can produce several distinct types of hazards simultaneously. As advancing ice pushes into a valley, it can block rivers entirely, forming dammed lakes behind the ice. Now, when that ice eventually breaks or weakens, these lakes can release sudden, devastating floods downstream, essentially the same underlying mechanism behind the glacial lake outburst floods we discussed when covering Juneau, Alaska's recurring suicide basin flood, just triggered by advancing ice damming a valley rather than meltwater trapped in a basin. Beyond flooding, sudden detachments of glacier ice during a surge can trigger large ice and rock avalanches. The high ice velocities involved in a surge cause widespread crevassing, deep cracks opening across the glacier's surface, which the research specifically notes makes travel extremely hazardous in regions where local glaciers function as routes between settlements or provide climbing access to mountain peaks. When surging glaciers reach the sea, they can release large numbers of icebergs in a short period, creating hazards for shipping and marine tourism in coastal areas. Taken together, these represent a genuinely wide-ranging set of risks: flooding, avalanches, blocked travel routes, and marine hazards, all stemming from the same underlying phenomenon. To understand what this looks like in practice, consider the Shisper Glacier in Pakistan's Karakoram Mountains, one of the case studies researchers specifically point to. According to phys.org, an unstable lake formed when the surging Shisper Glacier advanced and blocked a river valley, and that lake drained multiple times between 2019 and 2022, each release causing extensive damage to the Karakoram Highway, one of the most important overland connections between Pakistan and China. One of those floods destroyed the Hassanabad Bridge in May 2022, a critical piece of regional infrastructure, illustrating precisely the kind of repeated, unpredictable damage a single surging glacier can inflict on a community and its transportation network over just a few years. Here's the part of this research that carries the most significant implications going forward. According to the University of Portsmouth, climate change is making surge behavior increasingly unpredictable, including documented cases where extreme weather events triggered surges earlier than models had expected. This runs somewhat counter to the more commonly discussed climate story around glaciers, which usually centers on straightforward melting and retreat. Surging glaciers complicate that picture considerably, since a warming climate doesn't simply make them melt faster in a predictable, linear way. It appears to be actively destabilizing the specific meltwater and pressure conditions that trigger a surge in the first place, making the timing and intensity of these events genuinely harder for scientists to forecast using historical patterns alone. This distinction matters enormously for the communities living near these glaciers. A slowly retreating glacier, while still a serious hazard in its own right, as we discussed regarding Alaska's Barry Arm landslide risk, at least tends to change gradually enough that monitoring systems can track its evolution over years. A surging glacier, by contrast, can transition from apparent dormancy to rapid dangerous advance within a comparatively short window, precisely the kind of scenario that makes advance warning and evacuation planning considerably more difficult to execute effectively. The study's authors have been direct about what needs to happen next. According to the Weather Network, the researchers are calling for significantly increased glacier monitoring, primarily through expanded satellite surveillance combined with improved computer modeling and projections, and more. Direct field observations of at-risk glaciers. Dr. Lovell emphasized that the increasing unpredictability documented in this research means the scientific community needs considerably better surveillance and forecasting capabilities than currently exist, a call that echoes the broader theme we've discussed repeatedly on this channel, regarding glacier-related hazards, from Barry Arm's landslide monitoring to the detection network that successfully identified Alaska's Tracy Arm megatsunami in real time. In each case, the fundamental challenge is the same. These hazards are becoming more consequential as glaciers respond to a changing climate, precisely as the tools needed to monitor and predict them are still being actively developed and refined. This research adds a genuinely important third category to the pattern of glacier-driven hazards we've explored on this channel this year. Barry Arm in Alaska represents a landslide risk created by a retreating glacier removing physical support from an unstable mountain slope. Juneau's Suicide Basin represents a predictable, near-annual glacial outburst flood tied to a basin trapped against retreating ice. Surging glaciers represent a third, distinct mechanism entirely, ice that isn't retreating at all in the traditional sense, but instead periodically accelerates forward with enough force to dam rivers, trigger avalanches, and destroy infrastructure, all while becoming progressively less predictable as the broader climate around these ice formations continues to shift. Researchers involved in this study continue expanding satellite-based monitoring of the 81 highest-risk glaciers identified in the Karakoram Mountains and other hotspot regions, working to build better predictive models for when and where the next major surge might occur. Given the documented case of Shisper Glacier's repeated flooding between 2019 and 2022, regional authorities across the Karakoram, along with similar high-risk zones in the Arctic and Andes, face an ongoing challenge in balancing infrastructure planning and community safety against a hazard that, by the researchers' own admission, is becoming measurably harder to forecast using historical data alone. There's a genuine strangeness to learning that some glaciers respond to a warming planet not by simply melting away, the pattern most people have come to expect, but by periodically gathering themselves and lurching forward with enough force to dam rivers and flatten bridges. That's precisely what makes this research worth understanding clearly. The climate story around glaciers isn't a single uniform narrative of retreat. It includes this smaller, more volatile category of ice that behaves almost unpredictably by comparison, sitting dormant for years or decades before suddenly becoming one of the more dangerous natural hazards a mountain community can face. With 81 of the world's most dangerous surging glaciers now specifically identified, largely concentrated above populated valleys in the Karakoram Mountains, the researchers behind this study have taken a significant first step toward understanding exactly where this risk is concentrated. Turning that understanding into reliable, advance warning for the people living beneath these glaciers remains, by their own account, a work very much still in progress. We'll keep tracking this story and every other major seismic, volcanic, and extreme weather event happening around the world right now. Subscribe if you want to see the next update. Drop a comment and tell me, had you ever heard of a surging glacier before today? See you in the next one.